Hey there and welcome to Brain Stuff. I'm Josh Clark and this is the Brain Stuff where I explain to you how carbon-14 dating works. Carbon-14 dating, which we also just call carbon dating, is a form of radiometric dating. And all it is measuring the decay of a certain type of atom found in a once living organism to determine when it was last alive. And all of this starts in the upper atmosphere of Earth, where it's constantly bombarded by cosmic rays. And one of the things these cosmic rays do is knock neutrons off of some atoms and protons off of others. And before you know it, the nice, stable, family man nitrogen-14 atom is all wrapped up and gone crazy and becomes what's known as a carbon-14 atom, which is radioactive. Now, carbon-14 atoms aren't the only ones in the upper atmosphere. There's also carbon-12 atoms. Carbon-12 atoms are in much more abundance and they're pretty stable. Carbon-14 atoms are, again, radioactive and unstable, but they're formed at a reliable, steady rate. So at any point in time, we have a pretty good idea of the ratio of carbon-12 atoms to carbon-14 atoms. Got that? It's important. Now, carbon dioxide is essential to life here on Earth. Plants breathe it in, animals eat the plants, we eat the animals and the plants, and these carbon molecules, carbon-14 and 12, that make up the carbon dioxide, get in everything. What's neat is that the ratio of carbon-12 to carbon-14 found in all these living things here on Earth is pretty much the same as what's in the atmosphere, which means it's predictable. And some very, very smart scientists have figured out that carbon-14 actually decays at a predictable rate, right? Carbon-14, like all radioactive particles, has what's called a half-life. Now, the half-life is the amount of time it takes for the number of radioactive particles in a sample to decrease by half. Carbon-14 has a half-life of 5,730 years. That means that after 5,730 years, the amount of carbon-14 atoms in a, say, plant that you found fossilized will be half of what it was the last time that plant took, well, a breath of life. After 11,460 years, which is 2 half-lives, there'll be a quarter the amount of carbon-14 that was originally present. And then after 17,190 years, you'll have just an eighth of the number of carbon-14, and so on until there's none left. And this is actually one of the limitations of carbon-14 dating, that eventually you're going to go far enough back in time that all of the carbon-14 atoms have decayed. And you don't know whether this took place a day before or 100,000 years before, which means the time limit that you can date things using carbon-14 is roughly 50,000 years. But as long as you are trying to date something that lived on Earth within the last 50,000 years, you can figure out roughly when it was last alive. And the way that you do that is by measuring the rate of decay of carbon-14 atoms compared to the slow and steady carbon-12 atoms that are also present in there. Presto, changeo, you've got some carbon-14 dating, and all of a sudden you say, oh my God, this wooden axe handle is 12,000 years old. Pretty sweet stuff. And this whole thing gets even more interesting when you realize that future archaeologists are going to have a lot of trouble using carbon-14 dating thanks to us, humans of the present time. Our industrial activities have been pumping CO2 into the atmosphere and really messing with the ratio of carbon-12 to carbon-14. And even more astounding, all of the nuclear bombs that we set off in the mid-20th century, well, those messed with the atmospheric ratios too. So good luck with all of that, future anthropologists and archaeologists. Sorry.